Hello, I'm going to review section 4.6, which is talking about imaginary numbers. So I'll get started by talking about what an imaginary number actually is. Imaginary number comes from starting off that the square root of a negative number never had a real answer. So what we did is define something by the letter I, and we set it equal to -1. So in other words, if you ever had to simplify something like the negative square root of 16, well, you know that the square root of 16 is 4, and the square root of -1, like I said, is defined as I. So what you actually could do is take the square root of 16, take the square root of -1, and now your simplified answer would be 4I. So now that you kind of hopefully get an idea of what I actually is, again, it's just the square root of a negative number, which is something that's not real. What we're going to do is simplify a couple other expressions that use I, talking about different powers. So before I even get to that, I'm going to make a small little box off to the side where I'm going to give you 4 values of I. We have I to the first power, I to the second power, I to the third power, and I to the fourth. These are really insanely important values. So first of all, like I said, we define I as just being I itself, which is the square root of -1. I squared, if you take the square root of -1 times itself, the square root of -1, the radical sign would go away and you would be left with -1. If you take I to the third power, I would break this up into I squared times I. And like I said, the square root of, I squared is -1. And if you take -1 where my cursor is, -1 times I is -I. And then lastly, I to the fourth, I can rewrite as I squared times I squared, which would be the same thing as taking -1 times -1. So what that means is I to the fourth power is 1, which is really helpful when it comes to simplifying these first 3 problems where you have these insanely large numbers for exponents for the power of I. So there's kind of a nice little trick to this. The first thing we're going to realize is that if we know how many times I to the fourth power can go evenly into 55. Every time we say I to the fourth, it simplifies to 1. So what I'm going to do in my calculator is take 55 divided by 4 in the calculator, and I get 13.75. What that means is that I to the fourth power evenly goes into 55 13 times. Okay, it's because 13 times 4 is 52. You have a remainder of 3/4 of an I left, so that's where this 0.75 comes from, which I'm going to express as I to the third power. So again, if you do 13 times 4, you get 52, and then I have this I to the third as a remainder, and that would give me a total of 55. So the point of doing this is that I know that I to the fourth power is 1, and 1 to the 13th power is just 1 as well. So when I take 1 times I to the third power, if I go over here, I to the third power is -I. It simplifies to 1 times -I, which is -I. So this giant expression up here, I to the 55th, can be expressed as -I. Oops. All right, next one. I to the 17th. I'm going to do this the same way. I'm going to take 17 and divide it by 4 first, and I get 4.25. So what that means, again, I to the fourth power can go into 17 a total of 4 times evenly, and you have a remainder of I to the first power left over. So again, I to the fourth power is 1, and I bring down this I, which was my remainder. 1 to the fourth power is 1, and 1 times I gives us I. So like I said, I to the 17th power can be reduced to just I. Last one, I'm going to take 522 and divide that by 4. And I put in the calculator, I get 130.5. What that means, again, I to the fourth power is evenly going to go into 522 a total of 130 times. If you take 4 times 130, you'll get 520, and you get this leftover of 0.5. So 0.5 means you have 2 out of the 4 i's left, so I squared is left over. Bring down this part, which I'm going to write as 1 to the 130th power. And I'm going to bring down I squared using my little handy table over here. I squared is -1. So then at the very end of this problem, 1 to the 130th power is 1, and 1 times -1 is -1. Okay, so those are just some of the ones that involve simplifying with I. What I'm going to do with the problems to the right then, or with the problem to the right, with number 4, is simplify an expression that involves having I in there. It looks like a polynomial, and it has a bunch of i's. So I wouldn't call this a polynomial because I to the third power is representing a number and not a variable. Even though it's an imaginary number, you wouldn't call this a polynomial. But it's going to simplify, similar to how one will as far as like terms go. Where at the very end, if we have i's left over, you'll be able to simplify some of those. But what we're going to try to do is get rid of things like I to the fourth power being 1 and I to the second power being -1. So yeah, first thing, bring down the -4 because that's a nice solid whole number. Oops. So I'm going to bring down -4. I'm going to rewrite this as 3 times. Now, like I said before, I to the third, we just called -I. And then I'm going to rewrite this I to the fourth as +1. And then I'm going to rewrite I squared as -1. So that was just using those 4 values. Again, we just let I to the first power be called I. We said I to the second power was -1. I to the third power was -I. And then I to the fourth power was 1. Okay, so now I'm going to simplify this again, bring the -4 down. This is going to turn into -3i plus 2, and then this very last part is going to turn into a +7. And then what you want to do is take all the real parts, so the things without I, and we're going to simplify these and write that number first. -4 plus 2 is -2, and -2 plus 7 is 5. And then we're going to bring down the imaginary part after it. So there's the real part, which is 5, and the imaginary part, which is -3. So that's what that expression would simplify to. The next problems, what we're going to do is calculate a product for each of these, which is just basically using the distributive property. You can think of I again like it's a variable, even though it's not a variable, it's a number. You can treat it like it's a variable, so we're still going to multiply with it, except it'll simplify a little bit differently. So again, I'm going to rewrite those 4 values of I off to the right that simplify pretty nicely. Oops. Whoa, whoa, whoa. Let's try that again. Okay. I equals I squared is -1. I to the third power we called -I. And then I to the fourth is 1. Alright, so first one. You're going to distribute this 2 through each of these values in the second parentheses. 2 times 3 is 6. 2 times -3i is -6i. And now I'm going to do the distributing of the I through. So I times 3 is +3i. And then I times -3i is -3i squared. So watch how I'm going to simplify this. Take your time on this. First thing I'm going to do is bring the 6 down. I'm going to combine these two, which -6i plus 3i is -3i. And then what I'm going to do here is replace the I squared with -1. Because again, I squared is -1. So last thing we can do is simplify this again, I should say. We're going to take 6 minus 3i, and then this part right here is going to simplify to +3. And then your last step, combine the 6 and the +3 to get 9, and then bring down the -3i as the imaginary part. And that is all for that. With the next one, I would definitely recommend pausing this video, try number 6, and then play it to see your solution. I'm going to distribute again. So 4i times I, this time my 4i squared came first. 4i times -1 is -4i. Now I do the inside part where I have -3i, and then I have a -3 times a -1 is +3. So again, what I'm going to do is replace my I squared first with a value of -1. I'm going to combine these two, so -4i minus 3i is -7i. And then I'm going to bring down the +3. Next thing to do is multiply 4 times -1 is -4. And bring down the rest of the equation. And again, you can combine only the real parts to this first. So -4 plus 3 is -1. And then you'll bring down the imaginary part, -7i. Okay, so it simplifies pretty nicely. Last one. This one looks kind of strange at first, -6i squared. There's a couple ways that you can think about this problem. You can either rewrite it out as -6i times itself, -6i, or you can use a rule of exponents, which is to take -6 and square it, and then take the I and square it. -6 squared is positive 36, and I squared is negative 1. So if you took this original expression from number 7, it would simplify to negative 36. Okay, so that was simplifying products using I. The next ones, what we're going to do is multiply just like we did, except these are what we call conjugates of each other. So this is a vocabulary term where what you do is you start with an expression like 6 plus 2i. And the conjugate to that means what you're going to do is switch the sign of only the imaginary part. So even if the 6 were a negative, you would still keep it negative over here because the 6 represents the real part of the number, the 2i represents the imaginary part. So like you can already see in number 9, the 4 is the real part in each of these, and since it starts off with negative 3i, the conjugate would be plus 3i. So there's kind of a nice little trick to doing these. I'm going to multiply the first one out, or number 8 first, so that you can see the whole thing. And then what I'll do with number 9 is kind of use a shortcut. So the first step, 6 times 6 is 36. And then I'm going to have 6 times negative 2i, which is negative 12i. But then notice the inside. I'm going to have a positive 12i, which is going to be nice because that means that these middle terms will cancel out. And then my last term is 4i squared. So the nice part about conjugates is every time you multiply a pair of conjugates, these middle terms are going to drop out. And any imaginary number, when you multiply it by a conjugate, is going to turn into a real number solution. So I'm going to bring down this part right here. Again, I'm going to replace the I squared with negative 1. And that means what you really have is 36 plus 4. So that whole expression, when you multiply it through, if you take 6 plus 2i and you multiply it by its conjugate, you'll end up with positive 40. So again, I would encourage you to pause the video, try number 9, and then check your answer. What I'm going to do is just multiply the first terms and the last terms because, again, I'm identifying that these are conjugates so that the middle terms will cancel out. So I'm going to take my first times my first. 4 times 4 is 16. And then I'm going to take my negative 3i times positive 3i, and that's going to give me negative 9i squared. So again, you're going to bring down the 16 and the negative 9, replace the I squared with negative 1, and it becomes 16 plus 9, which is 25. So that expression, again, when you multiply it by its conjugate, comes out to a real number, which in this case is 25. Next ones, we're going to use the conjugate now just basically to get the I out of the denominator. So what we want is a real number on our denominator, and since we have I down there, I know that we can multiply by a conjugate and it'll get the imaginary part out of there. So what I'm going to do is take the top of this equation and the bottom and multiply it by the conjugate, which is 2 plus I. And the reason we do this is because whenever you multiply any number, I don't care if it's the number 5, if you take the number 5, or I'm sorry, if you take a fraction like 5 over 6 and you multiply it by something over itself, like if I take 1 over 1, it still ends up coming to itself. So the point of multiplying by something by a conjugate is we're going to get a different looking answer in the very end, but the value itself will still be the same. We just don't want I in the denominator. So you're going to have to do the distributive property on the top and the bottom. The nice part about the bottom is that, again, with it being a conjugate, the middle terms are going to cancel out, so you only need to multiply the first and last terms. But for the numerator, you'll have to distribute that entirely. So 4 times 2 is 8. I have 4 times positive I, which is positive 4i. The inside is going to be I times 2, which is 2i. And then the last part is I times I, which I'm going to write as I squared. The denominator of this, again, I'm going to take my first times my first, so 2 times 2 is 4, and then just do your last one times your last one. Like I said, the middle ones will drop out. Negative I times I is negative I squared. So now I'm going to bring all this work down. I'm going to bring the 8 down. I'm going to simplify these two. 4i plus 2i is 6i. And then I'm also going to simplify that I squared is negative 1. On the denominator, I have 4 minus, and again, I'm going to replace the I squared with negative 1. So now, at the very end, my numerator, I have 8 minus 1 is 7. So 7 plus 6i is your expression. You cannot write that as 13i because, again, I is kind of like a variable where you can only combine like terms. On the denominator, I have 4 minus -1, which comes out to 5. So this would be the simplified form of, again, this expression. So once again, please pause the video, try this last one yourselves, and then play it. I'm going to go through the solution, which again, we're going to multiply by a conjugate here. I'll use even the same colors as I did before. So in this case, my conjugate, this expression can be written as 3 plus I. So what we're going to have to multiply it by is 3 minus I. Okay, so again, what I'm basically going to do is rewrite this expression to be 3 plus I. And the reason for that is you want that imaginary part to be the part that changes when you multiply it by a conjugate. So I'm going to do the top and the bottom by 3 minus I, and then I'm going to distribute. So on the numerator, I have 3i times 3, which is 9i. I have 3i times negative I, which is negative 3i squared. 2 times 3 is 6, and 2 times negative I is negative 2i. On the denominator, now that I rearranged these terms, I can do the first and last trick. So 3 times 3 is 9, and then I have a positive I times a negative I, which is negative I squared. So to simplify this, on the top, I'm going to take this 9i and minus 2i, and I'm going to call this 7i. I'm going to replace the I squared with negative 1, and then I'm going to bring down the plus 6. On the denominator, I have 9 minus I squared is negative 1. So I'm going to bring this all the way over here and simplify it. Almost done. This whole number part on top, this is going to come out to 7i 7i plus 3 plus 6, and the denominator comes out to 9 minus negative 1, which is 10. One more step. Take the real number part and write that first. 3 plus 6 is 9. Bring down the plus 7i, and that whole thing is over 10. So again, to multiply the conjugate on the bottom, we got rid of the imaginary part as the denominator. Even though it's on the numerator, our goal was just to basically get it out of the bottom of that fraction. One more problem left. So what we're going to do is solve a quadratic equation that would have 0 real solutions, so only imaginary solutions, which we can do by simplifying it using I. So the first thing we're going to do is label what our A, B, and C values are so we can substitute them into the quadratic equation. A value is negative 2, our B value is negative 3, and your constant term is negative 4. So just to refresh your memory, I'm going to write the quadratic formula up here, which is opposite b plus minus the square root of b squared minus 4ac, and all of that is over 2a. And now I'm just going to start substituting values in. Nothing special at first. I'm just going to copy things over. So the opposite of b is negative 3, plus minus the square root, and I'm going to put it in parentheses again, b squared minus 4 times a times c. And all of that is over 2a. Okay, so the next step then is simplify a little bit on the inside. I'm going to rewrite this as positive 3 then, because it's negative negative. So 3 plus minus the square root. And I'm going to simplify negative 3 times negative 3 is 9. And it's going to be negative 4 times negative 2 is positive 8. But positive 8 times negative 4 is negative 32. And then on the denominator, I have negative 4. So I'm going to simplify this again, bring it down another line. I end up with 3 plus minus the square root of 9 minus 32, which is negative 23. And all of that is going to be over negative 4. And now again, since we have a negative number underneath the radical, that would mean your discriminant is less than 0. So you would have 0 real solutions. But we're going to take one more step then and simplify this by basically taking the negative sign out in the form of an I. So I'm taking really negative 1 times 23. So I'm breaking apart this radical. The square root of negative 1 is I. And then you're left with the real part of 23 on the inside over negative 4. So Again, the point at the very end there was that you are bringing out the negative sign in the form of the letter I, because again, the square root of -1 is I.